In this example, we would like to see the integral of a vector field through a complicated path. Initially, this path looks very complicated. As you can see, it has a exponential with a quadratic function and a cosine and a high power of t. So it seems to be a very complicated path. However, for problems like this, intuition should tell us that we should check whether the vector field is conservative in order to apply the fundamental theorem of line integrals. That's the first thing that we will do. Observe that the two partial derivatives in question match, so it happens that f is conservative. The fundamental theorem of line integrals tells us that the integral of a conservative vector field depends only on the starting and ending points of the path in question. And the result is the potential function of the field evaluated at those endpoints. So first, we will find a potential function. We integrate the first component of f with respect to x to receive this function, plus a possible constant function which depends only on y. This function can't be detected by the integral with respect to x because it depends only on y. So we will differentiate it and compare it with the second component of f in order to identify what this constant function is. This over here is the result of integrating, the result of differentiating what we integrated first, and this over here is the second component of our original vector field. It must happen that then this c prime of y coincides with 2y in order to get then that c of y is y squared. It follows then that the potential is the sum of these two functions. We will take the constant to be 0. The endpoints of the path are what are left, if we do not recall what the values of the trigonometric function are at pi and minus pi, it helps to draw the function itself. With this graph, we have that at pi, the cosine function is -1, and it also happens that at -pi, it's also -1. Therefore, the curve has a starting point -1, -1, and endpoint -1, 1. The fundamental theorem of line integrals states the following. For a conservative vector field, expressed as the gradient of a scalar function, the integral through a path depends only on the starting points, and the result is the potential evaluated at the end minus the potential evaluated at the start. In this case, this is the potential evaluated at the end minus the potential evaluated at the start results in Therefore, the end result of this integral is 4 after evaluating the potential at the starting and ending points. In this exercise, thus, we have applied the fundamental theorem of line integrals and have seen that this result depends only on the potential of our original function and the starting and ending points of our curve.